All right, another installment of IXL skills. Today I'm looking at skills D.3 and D.4 for Algebra 2. And we're going to be using a function rule to evaluate functions. You've already had a little bit of experience with this, but also using a graph to find a function value. Kind of nice. And again, it is IXL. Sometimes it does require you to do work. So I have made my own little whiteboard using a sheet protector and a piece of paper and my own personal little expo markers. So it's something you could do at home as well. Or, of course, just have your trusty rusty lined paper out for you to do some work on in case you need it. This is not meant to be done in your head. It's meant to be done on paper just like everything else. All right, again, you may need to look at these little video to refresh your brain really fast. Please take notes if you need to. It's up to you, but you probably do need to show your works still using paper when you're doing your IXL skills. So function rules. So we're going to start with function rules, and then we're going to go to how graphs give us function value outputs. So example 1. Use the function rule to find f of 1. Given our function here is f of x equals the quantity 8 plus 2x quantity squared. Again, you can stop this video, pause, if you need to, rewind, kind of nice. Take your time. All right. So we want to find f of 1. You have done a little bit of this before, and this is the function rule. F of x equals 8 plus 2x quantity squared. And this is the rule that's going to generate an output for us. And here, f of 1 is telling, I have an input for you, an input value of 1. It's telling you that x is equal to 1. And it's saying, hey, go to your rule, and now we want you to, instead of using an x, we want you to plug in a 1. And so in the rule, everywhere you see an x, we're going to change it out and plug it in a 1. So we have 8 plus 2, and then instead of an x, we're going to plug in a 1. And again, be careful plugging things in. You're just plugging it into the x itself. Don't forget about everything else. And it's always a good idea when you're plugging something in, you're going to use parentheses. Let's see, I'm going to multiply inside the parentheses first, order of operations. So I'm going to do this little bit. 2 times 1 is 2. Inside the parentheses, I'm going to add. 8 plus 2 is 10. And then, of course, 10 squared is 100. And so f of 1 equals 100. And this is just function notation. This told me I had an input x value of 1, and it's going to give me an output value of 100. And so x equals 1 and y equals 100 is really just an ordered pair that we can see graphically as well. So sometimes we're going to be given a rule. This is an algebraic expression, an algebraic rule to give you an input and an output ordered pair. But maybe we just have a graph, and that's what we're going to look at next. I wanted to show you also that once you plug in the 1, if you wanted to just use your calculator, you could type it in very, very carefully, of course. We know that using your calculator is key. So I'm going to, everything with parentheses, just like I have here. Notice the double parentheses here, to the second power. And lo and behold, I get 100 as well. So you can do it by hand or you can use your calculator. You can do either. Over here, these funky little symbols are absolute value. And on your calculator, you'll see ABS for absolute value. So you can use your calculator. I will show you how to do that as well. So for this one, we want to find f of negative 5. So we have an x value equal to negative 5 as our input. And we want to go to our little rule here and plug that value in. So everywhere we see an x, we want to plug in a negative 5. So I have negative 4 minus 8. And inside the absolute value here, we are plugging in a negative 5 in place of the x. Now, absolute value means and hopefully you already know this, absolute value means that whatever is inside the absolute value, you would want to simplify inside those absolute value bars first. Once you simplify, then to evaluate an absolute values refers to distance, the distance between -5 and 0. And distances, geometrically speaking, are always positive. And that's what absolute value is saying. And so basically it says everything that comes out of the absolute value bars is going to end up being positive. So the absolute value of -5 is 5. The absolute value of 12 is 12. The absolute value of -24 is 24. Always, always. This 8 is right next to the absolute value. And of course, anytime you have things right next to each other, it means multiply. So I'm going to go ahead and bring down this other stuff. So this is -8 times 5. We want to multiply first, order of operations. -8 times 5 is -40. And a -4 and a -40 is -44. So f of -5 equals -44. So we had an input of -5, output of -44. On the TI, if you wanted to try doing that in your calculator, again, we can type it in just like we have it written out here. So I'm going to do -4 and then -8. And I want to find absolute value. On the TI, absolute value is in the math menu. So you go to math. And we're going to arrow over to num. And ABS is the very first thing there. You can see it's ABS. And you can see on my calculator, if you have a newer version like an 84, then it gives you the bars. And I can just type in -5. If you have an older model, it might just literally have ABS, and you'd want to make sure that you put -5 in parentheses for it. And you can hit enter, and you see we get -44. You can do the same thing on a Casio. So here's my Casio calculator, and we're going to go to the run menu. So that's in the menu here. And sorry, I want you to see the screen as you normally would. So I'm going to go ahead and type in -4 minus 8, and then I want to find the absolute value. Option is a really good button on your Casio calculator. So you press option, and then up here we have the more arrow. You can see I'm going to press F6 because I want more options here. And you see number as well, and number is under F4. And then ABS is the very first choice. And again, that's absolute value. You see it's just ABS, so I want to put in parentheses -5 so that it knows it's the absolute value of -5. And again, we get -44. So you can use your calculator for those things. It's good to know where those functions are. So again, what we're finding when we're doing these function notation is that we have an ordered pair. We plugged in -5 for x, and we're getting an output or a y value of -44. And so when we see a function notation like this, it's really saying if you have an input or an x value of -5, what is the output or the corresponding y value? So that's what we want to find when we're given a graph like this one. Example 2, use the graph to find g of -4. And so what this is saying is I have this great graph here, and it's what we call a piecewise function, and it's just made up of pieces of graphs. So what you'll see on IXL, it might be a nice little parabola, or it might be something like this, where it's little things pieced together. So first of all, this is my graph. It says the y value is g of x. So this is some generic graph. And so we have an x-axis here, and we have the y-axis, the outputs. And so if we have basically an x value equal to -4, this is asking, hey, what is the corresponding y value? And so you can just look at our graph. We're going to go to the x-axis where it equals -4. Well, right here is -4 on my x-axis. And we're going to go and find the corresponding output value. So where does the graph appear? Right here is the output value, -4, 1 to -3. And so when we have an input value of -4, the output value is -3. So we're just really finding the coordinating point on our graph. So you can see the input, output, ordered pair, -4, -3. Now, we want to find g of -2. Well, again, this is saying go to the x-axis and go to -2 on the x-axis. -2 is right here. But this is an interesting thing on this graph. We have what looks to be two ordered pairs. There's one above right here and one below down here. So which one do you think it is? First of all, it can't be both. There should only be one output value. In order for this to be a function, you can only have one output value. So it can't have both answers. And so this point down here is an open circle, and that means it's not included. We get really close to this point, but it's not actually the point -2, -3. That point is not really there. This point uses a nice solid dot. That one is included. See, oh, I spelled it wrong. C-L-U-D-E-D, there we go, is included. And so because it's a nice solid dot, this really is the point -2, 1 in this case. And so we're going to take that answer. G of -2 gives us an output of 1 on our graph. G at 0, x is 0, is right here. And here's the point right here. That'd be the point 0, 1, 2, 3. So G at 0 is 3. So you're really just looking for the ordered pairs. And G of 5, x is equal to 5 right here. And we want to know where's the output. Right down here. That's the point 5, -1, 2, 3, -4. So input of 5, output of -4. And so that's what it means when you have function notation. They're asking if your input is 5, what's your corresponding output? So basically finding XY ordered pairs. All right, you guys should be able to do skills D3 and D4. Remember, your goal is to get an 85 or better. But if you get an 85 and you're like, I'm good, I get it, you can just leave the program. IXL is going to save your score for you, and that's what it is. So don't feel like you have to get 100. Your goal is just to get an 85. Of course, if you want to get a 90 or a 92 or 93, that's totally your choice. Whenever you feel you've learned enough, just go ahead and close the program. You're done.